What's happening, dogs? Mr. Allen here with a little bit of algebra mixed into geometry. I love doing that. All right, we got some triangles here. Looks like we got a little extension going out past that triangle, which is interesting. And I got to solve for x in each one of these examples. Okay, so this right here is called an exterior angle. It's outside of the polygon we're talking about, in this case, a triangle. Exterior angles can exist with quadrilaterals, pentagons, hexagons, any polygon, right? But when it comes to a triangle, the exterior angle here is equal to the sum of these two remote interior angles, all right? Which is super convenient for this one right here, right? I can take that 12x plus 10 and set it equal to 60 plus 70. Beautiful. So we got ourselves 12x plus 10. I like to clean up the right-hand side, or either of the sides, right, before I start moving things from one side to the other. So I'm going to have, what, 130 here? Subtract 10, I get 12x equals 120. That's super easy to divide. I get x equals 10. It was asking us to solve for x, so we've done the job that we needed to do. Beautiful. Now you might be wondering, why is this angle here just magically equal to the sum of these two? Well, check this out. I'm going to call this guy right here, let's call this y. Okay, this angle will be y. I don't want to use angle BCA. It's going to muddy the situation up, okay? I know that angle A plus angle B plus angle Y, and I'm going to write it just as A plus B plus Y. I don't want to use any other notation here because it muddies it all up. All three of those have to add up to 180 degrees, right? Triangle, all the angles add up to 100 degrees, 180 degrees in a triangle. Cool? Good with that? I think we're good with that, okay? Now, I'm going to call this angle out here, this big guy right out here, I'm going to call that one Z, okay, for this particular situation, just to model what's going on here. I know that Y and Z, they add up to that straight line there, right? So that's going to add up to 180 degrees. So Y plus Z equals 180, okay? Now, do we notice anything in common here? I've got this Y in both of them, right? But the difference here is that AB and Z, okay? But these two angles plus Y equal 180. This angle plus Y is equal to 180. Would it be logical to say that these two things have to be equal to each other to make both these statements true? If you just still don't believe me, check this out. A little bit more algebraic manipulation. What if I were to say A plus B is equal to 180 minus y, like I just subtract y over. And I'll do the same here. Z is equal to 180 minus y. Oh my goodness. I now have AB, Z on their own sides. They're both equal to the same thing, which must mean that A plus B has to equal Z. Okay, so my exterior angle is going to be equal to the sum of the two remote interior angles in any situation such as this. Okay, that's the reason why I find it helpful to know like why something works. If you're like, bro, I don't care, I'm just that equals that plus that. That's fine. But I think sometimes this helps make it click, and then you remember it later on instead of just trying to like grasp at mental straws in there. Anywho, let's get back to the algebra stuff. Right now, I have all x's here. But I know this angle, this is my exterior angle, is equal to, not this guy here, it's supplementary to that one. This one's equal to the sum of these two. So let's set that up. We're going to have 6x plus 32 equals 5x plus 2 plus 3x. Just enough room. Beautiful. All right, so now I have 6x plus 32 is equal to, that's 8x. Plus 2. Now I'm going to subtract the 6x over and subtract the 2. I'll write that out because that's kind of a lot of algebra happening all at once. I'm going crazy, dude. All right, so we got 30 equals 2x. Let's rewrite that as 2x equals 30. I think usually everybody likes the warm and fuzzy feeling when the variable's on the left-hand side, right? We could deal with it on the right-hand side. I know you guys can deal with it, but I just felt like writing it on the left, okay? So now I'll divide by 2 on both sides, and bingo, bango, we get 15 for x. And that's all it's asking us to do. If it asks us to find the angle measures, oh my, you guys want to find the angle measures? What if your test was like, find the measure of angle A? and you didn't know what to do because we didn't do it. I'm going to take care of that for you guys here. We're done with this problem as it's written, but I want to go the extra mile because I care about you guys, okay? If I plugged 15 in here, it would be 3 times 15. That's going to give me 45 degrees. But what if they're like, what's the measure of angle B? Well, we'll do that right down here. Direct substitution, baby. Throw 15 in there. Boom. 15 times 5. 5 times 10 is 50, right? And 5 times 5 is 25. That's 75 then. 77 degrees for angle B. Measure angle B equals. But what if they're like, bro, what about a measure of angle BCD? I thought you'd never ask. Let's do it, okay? So we got 6, then we got 15, plus 32. Oh, boy. Now these numbers are getting a little bit bigger, right? We got 6 times 10 is 60. 5 times 6 is 30. Then we got 60, 30, that's 90. So 90 plus 32, that's going to give me what? 122 degrees. So 122 degrees. All right. Now, question for you guys. What's 77 plus 45? That's 122 degrees right there, man. That's 122 degrees. That makes sense because this guy should equal that guy plus that guy, and it did happen. The math checks out. The math is mathing, guys. The math is mathing here. We just mathed it. I'm done saying the word math, but maybe math one more time. Math. See you later.